So hello guys, welcome to the channel. My name is Jayesh. I have qualified SET exam, GATE exam and NET exam. Okay, so we are starting our crash course on CSIR Physics 2025. Okay, where we'll discuss important topics and questions so that you can get maximum marks within a month. Okay, we know that the upcoming exam is in July, right? So I'm giving you assurance that you will get maximum marks if you follow this lecture series. Okay, it will be of a few lectures only and you can get the maximum benefit out of it. Okay, so please do like, share and subscribe. Okay, if I can get the certain amount of views, then only I can post the videos. Okay, so stay tuned and follow the lecture series. So right now we are discussing Laplace transformation. Okay, so you know that in in every CSIR net exam they ask question like 5 to 4 questions from this chapter, right? So this Laplace transformation is very important. Okay, so that's why we are starting this series with this Laplace transformation. So first of all, let's start our discussion. What is Laplace transformation? So we can write it this way, that f of s is equal to Laplace transformation of f of x. This f of s is also a Laplace transformation of f of x. Okay, and it is given as 0 to infinite e raised to minus sx f of x into dx. Okay, this is the way we find out the Laplace transformation of any function. Remember, Fourier transform is also very important, and that is also we are gonna discuss in this lecture series. So please stay tuned. Okay, there are few topics like differential equations as well. They also, you can find many questions from differential equation, right, in any CSI net exam. Okay, from any year. Usually they ask differential questions in part C. Okay, you can also get questions from Laplace, okay, in part C. So let's start. So before we okay, so let's start Laplace transformation. Okay, let's understand how to get a Laplace transformation. So first of all, you need to understand that Laplace transformation means if you are transforming any function, just do this way: apply 0 to infinite limit, then write e raised to minus sx and then given function and dx. That's it. This is our Laplace transformation. So first of all, what is the Laplace transformation of number 1? So it will be 0 to infinite e raised to minus sx multiplied by 1, right? Because here the function is 1 into dx, and we know that the integration of minus sx is e raised to minus sx divided by minus s 0 to infinite. So you will get e raised to infinite divided by minus s minus e raised to 0 divided by minus s. So e raised to infinite is 0, here it will be minus infinite, right? So e raised to minus infinite is 0, so we'll get 1 by s as our answer. So always remember, Laplace transform of number 1 is 1 by s. If we were finding Laplace transformation of 1 by 2, then just you need to multiply it with 1 by 2. That's it. That will be your answer. Okay. Alright, let's move further. Let's transform Laplace of any polynomial. Okay. For example, what is the Laplace transformation of x raised to n? So I'm not going into the derivation. It is directly n factorial divided by s raised to n plus 1. What is this s? This s is that which comes in Laplace transform. Okay, this one, see, 0 to infinite e raised to minus sx into dx into f of x, obviously. So this s is this one. Okay, so that Laplace transformation of any polynomial is n factorial divided by s raised to n plus 1. So Laplace transform of x square will be what? 2 factorial divided by s raised to 2 plus 1. It is very easy. Now, what about Laplace transformation of e raised to ax? Basically, what is the Laplace transformation of an exponential function? So Laplace transform of e raised to x is, let's derive its Laplace transformation. So we know that it is e raised to minus asx, then this function e raised to ax dx. So eventually it will be 0 to infinite e raised to minus a minus s, sorry, s minus a x into dx. So eventually you will end up with 1 by s minus a. Here the condition is that s should be greater than a, okay? That is the condition. Okay, now what about the Laplace transformation of sine function? What's the Laplace transformation of sine ax? So it is simply a by s square plus a square. In same way, Laplace transformation of cos ax gives us s upon s square plus a square. You can get confused between these two Laplace transformation. So to don't get confused, remember this thing, that in sine there is s, and in this formula in denominator it is also s, okay? So whenever you are working with sine function, the Laplace transformation of a sine function does not contain s in numerator. That is what you need to keep this in mind, okay? So that it will be really easy to remember both these formulas. Okay, what about the Laplace transformation of sine hyperbolic ax? So it is simply, you just need to replace this positive sign with negative sign. So it will be as square minus a square. Here it will be cos ax is equal to s upon s square minus a square. That's it. This is the Laplace transformation of cos hyperbolic function, cos hyperbolics ax. Okay, but the thing is, how did we end up with these results? So you can find it out by applying Laplace transformation this way, that it is e raised to minus sx multiplied by cos ax dx. Now you can integrate it, you will end up with this result, okay? You can do this integration with two methods. First one is u dot v method, that is u integration v minus integration du by dx integration v, or you can take this cos theta as e raised to minus ax plus e raised to plus ax divided by 2. Basically converting this cos function into exponential function, you can get your answer. Okay, now let's talk about its property. So properties are very important. Properties of Laplace. Remember, if you don't know the properties of Laplace transformation and you only know the formula how to convert the Laplace transformation, that's no use, okay? You must remember all the properties, then only you will be able to solve questions from the csirnet, okay? So I'll even mention some questions along the way, okay, so that you can get an idea how, what type of questions you can get in your csirnet exam. So first is linearity property. It is very easy. Laplace transformation of a1 f1 plus a2 f2 is basically a1 Laplace transformation of function f1 plus Laplace transformation of function f2. Second property is shifting property. What is this shifting property? So if you know the Laplace transformation of any function, okay, that is f of s, right? So you can find out the Laplace transformation, okay, of this thing. If let's say e raised to ax is multiplied with a function and you are required to find out its Laplace transformation, then it will become f of s minus a. You just got to replace this s with s minus a, okay? we can understand this thing by taking an example. For example, what's the Laplace transformation of e raised to bx multiplied by cos ax? So we know that Laplace transformation of cos ax is s upon s square plus a square, right? So you just got to replace this s with s minus a. In this case it is s minus b. Okay, that will be your answer. So s minus b divided by s minus b whole square plus a square. That's it. Very easy, right? So this is very important property, shifting property. I'm giving you some questions. Okay, you can try by yourself in homework. Okay, for example, what will be the Laplace transform of e raised to bx cos ax? Do it by yourself. Okay, alright. Also find out Laplace transformation of e raised to bx 1 by x. Okay, alright. Now let's move on. The scaling property, the third property. Now if you know the Laplace transformation of any function, let's say it is f of s, then the scaling property says that what? That Laplace transformation of f of ax is 1 by a f of s minus s by a. Okay, again Laplace transformation of f of ax is nothing but 1 by a multiplied by f of s by a. Okay, so let's see. For example, what's the Laplace transformation of cos square ax? So first of all you need to find out the Laplace transformation of cos square x, right? So remember, Laplace transformation of cos square x is s square plus 2 divided by s square plus 4. Okay, and how you can find it out? By just converting this cos square x into 1 plus cos 2x divided by 2. Okay, and you can get the answer, this answer. Okay, alright. So what is the Laplace transformation of cos square ax? So it will be simply 1 by a multiplied by, you just got to replace this s with s by a. Okay, so it will be s by a whole square plus 2 divided by s by a multiplied by s by a whole square plus 4. That's it. That is the answer. Alright, now let's move ahead and let's discuss fourth property. So fourth property says that if you know the Laplace transformation of any function, then you can find out the Laplace transformation of x raised to n f of x. That means if any function is multiplied by any polynomial, in that case the Laplace transformation is minus 1 raised to n d raised to n ds raised to n f of s. This f of s is nothing but the Laplace transformation of a function. So let's find it out. Let's understand this thing by taking an example. Let's say we know that Laplace transformation of sine 3x is simply 3 by s square plus 9, right? Now what will be the Laplace transformation of x sine 3x? So here as you can see, x is having one power, so it will be minus 1 raised to 1 d raised to 1 divided by dx raised to n dx raised to 1, and the Laplace transformation of a function, that is this thing, 3 by s square plus 9. Okay, here you can treat this thing as 1 by x, and we know that the differentiation of 1 by x is minus 1 by x square. So that way it will be minus 1 multiplied by 3 by s square plus 9 whole square multiplied by differentiation of this thing, that is 2s. So that will be our answer. Okay, let's move and talk about the next property, that is what will be the Laplace transformation of f of x by x. So it is simply 0 to infinite, not 0 to infinite, s to infinite. Laplace transform of that function into ds. Very important property. Okay, so for example, let's say what will be the Laplace transformation of sin x divided by x. So here in this case it will be 0 to infinite, and we know that the Laplace transformation of sin x is 1 by s square plus 1, right, into ds. And what is this thing? It is nothing but tan inverse s, right? So integration tan inverse s ds. So after the integration you will end up with pi by 2 minus tan inverse s, or you can say cot inverse s. So that will be our answer. Next property, 6.1, that what is the Laplace transformation of 0 to s f of x dx. That means what's the Laplace transformation of an integration? So it is simply 1 by s and multiplied by the Laplace transformation. This is the Laplace transformation, okay, not a function. So for example, what's the Laplace transformation of sin t? So we know that it is simply 1 by sin t, right? Sorry, 1 by s square plus 1, right? Yes. So what's the Laplace transformation of integration 0 to s sin x over x into dx? So it will be 1 by s multiplied by, we know that the Laplace transformation of sin x by x, it is cot inverse s, right? So that's it. That is the answer. Understood? Now let's understand the seventh property. That is the Laplace transformation of a derivative. So Laplace transformation of a derivative is given as s multiplied by Laplace transformation of a function, then the value of that function at x is equal to 0. So for example, we know that if we want to find out the Laplace transformation of cos x, so cos x is the differentiation of sin x, right? So this is our f of x. So f at x is equal to 0, so here in this case it will be 0, right? And we know that the Laplace transformation of f of x, that means sin x, is simply 1 by s square plus 1. So as you can see, okay, we already know what is the Laplace transformation of cos x, that is s by s square plus 1. But by this derivative method, we end up with this answer, right? So the general formula for the nth derivative is this way, that s raised to n Laplace transform at this of that function, then minus s raised to n minus 1 Laplace transform, the value of that function at x is equal to 0, then s raised to n minus 2 f dash at x is equal to 0, and so on. Alright, now Laplace transform of periodic function. Periodic function. So remember, Laplace transform of a periodic function is given by 1 by 1 minus e raised to minus st integration 0 to t e raised to minus sx multiplied by f of x dx. It is that simple, okay? You just got to place the value of that function and you'll get the answer, okay? For example, let's say our function is x square and it is having a period 0 to 2. Okay, so in that case the Laplace transformation of this x square will be 1 minus e raised to minus 2s integration 0 to t e raised to minus sx multiplied by x square into dx. Okay, so you just got to now integrate this integration. Okay, so I'm leaving this integration onto you guys, and it is probably good if you remember or memorize this integration. Okay, because it will be really helpful. I'm directly writing the answer, you can match the answer. Okay, 1 minus e raised to minus 2s 1 plus 2s plus 2s square, that will be the answer. Now Laplace transformation of a Dirac delta function, very IMP and my personal favorite. Okay, Laplace transformation of delta function. So it is very easy. Laplace transformation of delta x minus a is basically 0 to infinite e raised to minus sx into del x minus a. That gives us e raised to minus sa. Okay, you must memorize this result. Okay, it will be really helpful in the exam. All right, now let's take few exams and we'll wrap it up here. All right, so here the question is, we need to find the Laplace transformation of this function 2 sine 2x multiplied by cos 4x. Now remember, please remember all the identities. Okay, like this identity, what is this identity? It is nothing but sine a plus b minus sine a minus b. Okay, so here in this case we'll end up with sine 6x minus sine 2x. Here it is sine a cos b, right? So 2 sine a cos b gives us sine a plus b and sine a minus b. That way it is sine 6x sine 2x. So now it is very easy to transform. So we know that it will be a by s square plus a square, that will be 36. Now here it will be 2 by s square plus 4. So this will be the answer. Good. Now we'll discuss more examples in our upcoming session. Okay, please do check out other sessions that I'm about to take and stay tuned to the channel. Most importantly, please share this video so that I can bring more sessions. Okay, in this crash course we are gonna cover all the topics, all the subjects. Okay, it will be exam oriented. Okay, you can get the maximum marks out of these sessions, and trust me, I'm not gonna take 20 and 25 sessions per subject. Okay, I'm only going to give you few sessions per subject, but it will be really helpful. Even you can qualify for JRF using these sessions. So please share this session. Goodbye, take care.